Discrete mathematics is the study of mathematical structures that are distinct, separated, and countable. The best way to think about this is a jar. In this world, we aren't looking at smooth, continuous curves like you see in calculus. We're looking at individual, countable things, like marbles. You can have one marble, or you can have two, but you can't have half a marble, filling the gap between them. It's a step-by-step nature that makes it the foundation of computer science and engineering. Let's give it some formal names. The jar itself is called a set. The marbles within the jar are called elements. In other words, every single set contains an element. A set, put simply, is just a collection of objects. Now, there doesn't have to be anything in a set, but it's still called a set. And we'll look at more of those examples in future episodes of why that's the case. But as of now, all you need to understand is a set is a collection of objects. To show that the marble belongs to this specific set, we use this symbol. Now, this symbol represents an element in a set. So, for instance, I could say 1 is an element of the set S. Now that we know what a set is and what an element is, we can talk about the way we can write a set down. And there are 2 ways we can write a set. The first way is known as the set roster notation. So let's talk about that. The set roster notation. To use the set roster notation, we first need to label our elements, meaning that in our jar we have 4 elements. We can label it as 1, 2, 3, and 4. And so therefore, the set roster notation is going to be written in curly braces, importantly, and is going to contain the marbles we just labeled 1, 2, 3, and 4. Right? So that's the set roster notation. And that is the normal way of writing a set. So even in programming languages, you will see it being used by the curly braces. The next way we can write it is a bit more of a difficult way, but it makes sense, right? And this is called the set builder notation. Set builder. Notation. Okay, so the question is, if you had more than 4 marbles and you had 1,000,000 marbles, writing down 1,000,000 marbles using the set roster notation seems like a pain. So what we can do instead is we can write a bit of a condition. And in this case, the condition will look something like this. And then you will say X is a marble in the jar. Sorry for the handwriting, but... And what this means is that X is a marble in the jar with a condition, with a rule. That's what this means. And so when you write that little horizontal line, that line, it means such that. So you're saying X such that X is a marble in this chart, or X such that some other condition after that. That's what set building notation is. They're both used, but the reason why the building notation might be used is when there's too much to count, so we use a rule. And any number that falls in that rule is an element. In this example, the marbles are labeled as 1, 2, 3, and 4, and so the elements within the set are also 1, 2, 3, and 4. However, that's not always the case, so the elements in the set could be colors, car names, it doesn't have to be numbers. So these marbles could be labeled as the color of the marble as well. Okay, so now that we talked about the set roster notation and the set builder notation, let's talk about variables. So where do variables like x and y come in? In discrete mathematics, a variable is a symbol that acts as a placeholder for any element in our set. Imagine reaching into a jar to pick out a marble. So, imagine this is a hand. It's a horrible drawing, but it's a hand. And originally, let me make a better drawing actually of the hand. That looks ugly. So let's draw a better hand. Oh, yeah, let's just draw a circle. And let's just imagine that's a claw. That's a claw. Okay. And that claw is reaching in, and let's say it collects a marble. We don't know if that marble is blue, green, red, or another color. So to represent that unknown, that's what a variable is. X isn't a sliding value here. It represents one specific distinct object from our collection. It's the name we give to an element we want to talk about. So for instance, I could say that this blue marble is going to be X. X is equal to the blue marble. X can also be statements. So I could say X is equal to the weather is cold, for instance. Now, we'll talk more about this in future episodes because this comes under like statements and logic symbols, which we'll talk about as well. And a lot of variables that have statements assigned to it would be used when we talk about statements and logic symbols. So we'll look at that in the future. That's the core of it. Sets are the containers, and we talked about two ways of creating sets. The first one is the set roster notation, where we use the curly brackets, and the second way was the set builder notation, where we give a condition for X, the element, so we can talk about millions and millions of elements instead of writing it in a set roster notation. And finally, we have the variables, which are placeholders, which we can use to work with them. In the next episode, we are going to take these building blocks and start connecting them using logical symbols to build actual mathematical arguments. Thanks for watching, and make sure you comment down below if anything was confusing so I can, sort it out and help clear the confusion. Thank you.